So if we're going to talk about scientific notation, let's first talk about why it's useful. First and foremost, we spent all of last week learning about exponents and what exponents are and how they behave. Scientific notation gives us an opportunity to actually put what we know about exponents into play in real-world applications. So what scientific notation does for us is if I'm a scientist and I'm studying distances that are very large, or things or objects that are very large, like planetary bodies. Or maybe I'm a scientist that studies microorganisms, things that are really, really small. Scientific notation gives us a way to write really big numbers and really small numbers very concisely. Rather than talking about 423 billion and having to write the number 423 billion out every single time we talk about it, scientific notation gives us a way to write that big number very concisely. Same thing with very small numbers. Without listing a whole bunch of zeros to describe very small numbers, scientific notation gives us a way to write really small numbers really quickly and really concisely. So if we're going to write numbers, big numbers and small numbers using scientific notation, how can I look at a number and tell if it is written in scientific notation? A number is written in scientific notation if it has two features. The first feature is that the first part of the number being written in scientific notation has to be a number between 1 and 10. A number between 1 and 10. So down here you can see that we have examples of numbers written in scientific notation. For each one of these numbers, you notice that the first part of each number is written as a number between 1 and 10. 3.67 is a number between 1 and 10. 2.24 is a number between 1 and 10. 9.875 is a number between 1 and 10. So if a number is written in scientific notation, the first part of that number will always be a number between 1 and 10. The second thing that must happen if a number is written in scientific notation correctly is the second part of that number, it will always be multiplied by 10 to some integer power. Now, what are integers? Integers are negative numbers, 0, and positive numbers, right? So when I'm looking to determine if a number is written in scientific notation, the first thing I'm looking for is the first part a number between 1 and 10? Then I look to see if the second part of the number is an integer power of 10. So 10 raised to some positive or negative number or to the 0 power. So let's look at each of our examples here. The second part of the first number, the 3.67, is being multiplied by 10 to the 6th. Is that 10 raised to some integer power? Yeah. So the first number here, 3.67 times 10 to the 6th, is a number written in scientific notation. The second number here, the 2.24, is multiplied by 10 to the negative 4. Is 10 raised to the negative 4 power 10 raised to some integer? Yes, negative 4 is an integer. So the second number, 2.24 times 10 to the negative 4th, is also a number written in scientific notation. And finally, the last example, we notice that the 9.875, again, that's a number between 1 and 10. It's multiplied by 10 to the 22nd power, which is 10 raised to an integer power. So that number is also written in scientific notation. So now let's go back through each one of these examples. Now that we know that these are numbers written in scientific notation, let's talk about what kind of numbers each one of these examples are. So if we look at our first example here, 3.67 times 10 to the 6th power. When we look at that number written in scientific notation, can we look at it and determine if that's a big number or if it's a really small number? We can, right? 10 to the 6th power, if you were to put that into your calculator, 10 to the 6th power is 1,000,000. So really, we're multiplying 3.67 times 1,000,000. If we multiply 3.67 times 1 million, is that a big number or a small number? It's a big number, right? Yeah. And it turns out that when we're looking at numbers that are written in scientific notation, we can look right here. We can look at the exponent of the 10, and that will tell us if the number we're dealing with is a bigger number or a smaller number. If the exponent of the 10 is a positive number, that means we're dealing with a bigger number. Okay? Opposite of that would be when we look at the exponent of the 10. If the exponent of the 10 is a negative number, what kind of number do you think we're going to be working with overall? It's a smaller number, right? So when I'm looking at numbers in scientific notation, if the exponent of the 10 is a positive number, we're going to be working with a larger number. If the exponent of the 10 is a negative number, we're going to be working with smaller numbers. Okay? The last thing that we need to know is, what does this exponent actually mean? What does it actually do to my number? So let's look at the first example here again, the 3.67 times 10 to the 6th. If I start with the number 3.67 and then I multiply that by 10 to the 6th, multiplying that number by 10 to the 6th power essentially does what to that number? So anytime I multiply a number by 10, it moves the decimal place in that number one place to the right. If I multiply a number by 10 squared, it moves the decimal place 2 places to the right. If I multiply a number by 10 cubed, it moves the decimal place 3 places to the right. So a positive exponent of 10 causes me to move the decimal place that many places to the right, which essentially makes our number bigger. What about if I see, like in this example here, a negative exponent of 10? Well, if a positive exponent of 10 causes me to move my decimal that many places to the right, guess what a negative exponent of 10 does? It causes me to move my decimal place that many places to the left. Okay?